So in this session, we'll be studying some more instructions. Yesterday, we started with the first instruction of the data transfer group, that is move R1, comma R2. Second instruction that we'll be writing now from the data transfer group is move R, comma M. So B, what does this instruction basically do? It moves the contents of memory location whose address is in M into register R. Fine. So you will be given the address location where the data will be available, and you will be transferring that data into the register. Now this register can be any of the registers A, B, C, D, E, H, L. Fine. So we can write this as R M H L. Fine. So HL register pair will basically be carrying the address, and this address will be read by the microprocessor, and the contents of that address location. As I said, whenever M will be written outside, HL whatever is inside will actually refer to an address, and we are actually fetching the data from that address location. So the data is not in the HL register pair. The address is in the address will be specified by the HL register pair, and that address, from that address the data has to be moved to the register. Right? So moves the contents of memory location whose address is in M into register R. This is the macro detail of this. You know what to do now. I'm writing straight away. D, it's a single byte instruction. It's a single byte instruction. As you can see, we are actually the opcode will basically be taking a one byte, and no other byte is actually specified with this. The registers and the memory location, they will not be the byte itself, the data itself is not specified in the instruction, is not something that the register has to, the microprocessor has to basically operate in such a fashion that basically requires any other memory space. Fine. So it's a single byte instruction, but as far as the machine cycles are concerned, it has two machine cycles. As I said to you, opcode fetch machine cycle will be by default the first machine cycle of all the instructions. Apart from that, memory read machine cycle, because we are actually reading the contents from a memory location in this particular instruction. Memory read machine cycle will be one of the machine cycles of this instruction. F, opcode fetch machine cycle has 4 T states. Memory read machine cycle has 3 T states. The total T states will be 7. We'll be looking at the micro RTL memory read machine cycle shortly. F, then the execution time. So 7 into 0.32 microseconds, that is 2.24 microseconds of execution time. H, it has 7 variations. So R can be A, B, C, D, E, H, L, any of those. So accordingly, the examples will be move A, comma M, move B, comma M, move C, comma M, move L, comma M. So these will be the 7 variations of this instruction. And J, no flag will be affected, as no flag will be affected. As I said to you, the data transfer operations will not in general affect the memory flag, the flag register, sorry. Then you have the addressing mode. Now for every instruction from here on, we'll be writing 2 addressing modes. One is the source addressing mode and another one is the destination addressing mode. So what is the source addressing mode? That means where from are we obtaining the contents, the data. We are actually obtaining the content from a memory location whose address is specified in the register pair. So we have seen that if such a case arises, then it's register indirect addressing mode. And what is the destination? Destination is the register itself where the contents will be then moved to. So the destination is a simply we can say it's a register addressing mode. Fine. Then you have the micro RTL. So you have first the opcode fetch machine cycle, IO by M bar, S1, IO by M bar equal to 0, S1 equal to 1, S not equal to 1. Then you have T1, T2, T3, T4. In T1 what happens? First the address lines A15 to A8 address lines, they are loaded with the most significant bit of the program counter. AD7 to AD0, they are loaded with the least significant bit of the program counter, and the address latch enable is triggered. This triggering actually means that the address has to be latched by the microprocessor, because after this the data bus will be used for any other purpose as well. Fine, we know that. In the T2 state, the read instruction becomes active. It becomes active at 0. The program counter is incremented, and AD7 to AD0 is now loaded with the address location fetched from the address bus. Fine. The contents of the address location fetched from the address bus. So after this, in the T3 state, read will now become equal to 1. This is low to high transition, that and since this is an opcode fetch machine cycle, instruction register will be loaded with now the contents of AD7 to AD0, and in the T4 state, move R comma M will become equal to 1. So this is your first machine cycle, but in this case you have another machine cycle, and that's the memory read machine cycle. So what happens with the memory read, with the read operation? We have seen that for a read operation S1 will be 1, but S0 will be equal to 0. Fine. It has only three T states, T1, T2 and T3. Each will last for 0.32 microseconds. In the T1 state now, again the address bus has to be loaded, but what will be loaded onto this address bus? Where is the address? The address is in the register pair, HL register pair. So this address bus will be loaded by the contents of by the address that's actually located in the register pair HL, not by the contents of the HL register pair, by the HL itself. The most significant bit will be loaded onto A8 to A15, while as AD7 to AD0 will be loaded with the least significant bits of the HL register pair. HL register pair is a 16-bit register pair, as we have described it before also. Now in this particular case, in this particular instruction, HL register pair is basically holding the address of the memory location. So we need to read that. So like, using these two equations, using these two, in the T1 state, the address bus will be loaded with the contents of HL register pair. The most significant bit going to A8 to 15, the least significant bit going to AD7 to AD0, and address latch enable will be basically triggered. Fine. Program counter we have to do nothing with the program counter in this particular machine cycle. The program counter only keeps track of the instruction. So whenever the next opcode fetch machine cycle will be triggered, it will basically read this PC now. Fine. In the T2 state, the read instruction, since this is a read instruction, memory read machine cycle, the read instruction has to be enabled. So read instruction becomes active, and once the read instruction becomes active, AD7 to AD0 will be now loaded with the contents of that address bus. Fine. Once this takes place, read can become low again. There can be an increment, and whatever was on this address bus, on this data line, in the opcode fetch machine cycle, that's transferred to the IR register. But in this case, we do not need to transfer that to the IR register. We do not need to decode any instruction here. We already know what is the instruction, and that instruction is to load the register R with the contents on the data bus. So once this takes place, our instruction is complete, and this executes our complete instruction. So this will be how you will be basically writing the memory read machine cycle in future as well. The third instruction that we'll be doing is MOV M, R. Fine. So this is A. Now what happens with MOV M, R? Now the contents of the register will now be transferred to the memory location whose address is in M. Right? This is important. Moves the contents of register R into memory location. It does not move the contents of R to M. It moves the contents of R to the memory location whose address is in M. M is the HL register pair. Right? So the macro article of this MHL, the memory location, will be fed with the contents of the register. D, you have again a single byte instruction. You only need to decode the opcode that will consume one space in the memory. You do not need to write anything else onto the memory location. This single byte instruction, 2-byte instructions, once we actually start with the programming, they will become actually even more clear. E, it has 2 machine cycles. We can actually identify machine cycles. One machine cycle, the first machine cycle is always the opcode fetch machine cycle. In this case, we are moving the contents of register R to the memory location whose address is in M. Fine. So we are actually writing onto a memory location. So memory write machine cycle is involved here. Fine. So if you have memory write machine cycle is again of 3 T states. Opcode fetch is of 4 T states. So total number of T states will be 7. The execution time will again be 2.24 microseconds, that is 7 into 0.32 microseconds. H, how many variations does this have? It has 7 variations. And what are those variations? Examples of those variations: you have move M, comma A, move M, comma B, move M, comma C, up to move M, comma L. J. Uh, so one thing here you can see, actually there will be two variations: move M, comma H, and move M, comma L. HL register pair together, they are already carrying the address of the memory location. So once the address is fetched, only so we do not want, we need to make sure that HL actually in this case will not be actually carrying will be actually carrying the same data as well as pointing to the same address location. So these two can be more or less, you can say, redundant, and they will not be used more often. J, what will be the flag status? No flags effective. Fine, as I said to you, move M, comma H and move M, comma L. HL register pair is carrying the address. So HL cannot be carrying the data as well. So H or L cannot be carrying the data as well unless the address and the data is same. Fine. So you need to make sure about this while you are doing the programming. What you are. So this is a possible instruction. This will be executed by the microprocessor, but whether or not it will give you the right results, then that's up to the programmer. Now the addressing mode, the source addressing mode. What is the source? In this case, the source of the data is the register, so it's register addressing mode. What is the destination of the data? The destination of the data is the memory, but whose address has been given by the register. Fine. So it is register indirect addressing mode. JKL. Then you have the micro RTL. Micro RTL will be first the opcode fetch machine cycle. You have IO by M bar equal to 0. You have S naught, S1 equal to 1, S naught equal to 0. Sorry, S not equal to 1. Fine. In case of opcode fetch your machine cycle, this will be same. T1, T2, T3, T4. You have the 4 T states. What will be happening in all the T states? In the first T state, the T1 state, as we know, the address bus first will be loaded with the contents of program counter, and the address latch enable will be enabled. In the T2 state, the program counter is incremented by 1. Read signal is enabled. Once the read signal is enabled, 87 to 80 naught will be loaded with contents of the memory location that are on the address bus. In the T3 state, read is again disabled. Load by transition. Increment register will be loaded with the contents of the data bus. 87 to 80 naught will be loaded onto the increment register, and in the T4 state, finally the opcode will be triggered high. Right? This is your memory opcode fetch machine cycle. Now we have the memory write machine cycle in this case, not the memory read machine cycle. So IO by M bar is still 0. In this case, S1 and S0 S1 will be 0, S0 will be 1. In read, S1 is 1, S0 is 0. Now what's happening in this state A15 to A8, it is the contents of the HL register pair are first because they are carrying the memory location. So this is an address of the memory location. So that needs to be moved up onto the address lines. So contents of HL register pair are actually the location, the address of the location is actually moved to the address bus. Low and high, most significant bit and high, least significant bit, and the address latch is enabled. Address latch enable is triggered. That means now the data address has been read by the microprocessor, so the data bus can be taken up by for data execution. And in the T2 state, what happens is the write instruction in this case will be triggered. It will be made active. Fine. The write instruction becomes active, and whatever was on AD7 to AD, whatever was on the address bus, that has been actually read, and that needs that will be actually carried by the address as enable. But now we also need to know the contents that are in the register pair, because we are actually reading from where we are reading from the register pair. We are taking the data from the register pair. Fine, we are making that data available on the address bus, on the data bus, sorry. And in the T3 state, write instruction will be again disabled. There will be a low to high transition. And now what is going to happen? Address latch enable has already taken up the address bus from the HL register pair. That is already stored in the microprocessor. And what will be moved here? The contents of the data bus. The data bus is now actually carrying the contents of the register pair. So this is actually writing onto the memory location. So therefore this is a write instruction. Fine. So this T2 state here is important. See its difference from the opcode fetch machine cycle. The opcode fetch machine cycle and the memory read machine cycle, in both cases, what was being read in the T2 state? The contents of the memory location. But in this case, memory write machine cycle, if we have the contents are not in the memory, but the contents are in the register, we need to move the contents of the register onto the data bus in this case. So register contents are actually moved to the data bus AD7 to AD0. So this is your third instruction. So we have actually covered all the three. We have covered three machine cycles: opcode fetch, memory read, memory write. So most of your instructions will only be having only these three types of machine cycles. Only three machine cycles. I'm not saying that a particular instruction can have more than one memory write machine cycle. Will have more than one memory read machine cycle. So these three types of machine cycle will be there, but not only three will be there. That is not going to be happening. Fourth instruction that we are dealing with today is move MVI R comma data. So what does this instruction do? Moves immediately. What does it move? Moves immediately the data byte that's actually given here. what does this move this data to register R. So in this case, R will be moved, will be having this data. So say for example we have an instruction MVI A comma 32H. So what does this do? It simply moves this 32H to A, the accumulator. Fine. So it simply will move this data that's immediately given with the instruction itself to the register. Fine. So there is a data byte provided with this. MVI takes up 1 byte of space. This data will take up another byte of space. This is a 2-byte instruction. E, you have how many machine cycles? You'll be having again 2 machine cycles. And what will these 2 machine cycles be? You have the opcode fetch machine cycle and memory read machine cycle, because you are actually moving this data to the register R, but this data is actually stored in the memory, so we are actually reading from the memory location. 5 F, memory 2 machine cycles, you have opcode fetch and memory read, so it will have 70 states. G, it will have 2.24 microseconds of execution time. H, variations, 7 variations. I, what are those variations? You have move A comma data, you have move B comma data, you have move C comma data, move L comma data. Fine. This is I, J, K, J, no flag is affected. JK, addressing mode. What is the source addressing mode and what is the destination addressing mode? What is the source? The source is actually the data. That data is immediately provided, so it is immediate addressing mode. And what is the destination? It's the register. So the destination will be register addressing mode. Fine. JKL, and you have the micro RTL, you have the opcode fetch machine cycle. IO by M bar is 0, S1 is 1, S0 is 1, T1, T2, T3, they are same as in case of any opcode fetch machine cycle. And T4, what is T4 going to be? Move R comma data is going to be enabled. And then you have memory read machine cycle. In case of memory read machine cycle, IO by M bar is 0, S1 is 1, S0 is 0. Fine. Now you have 3 T states of this. Fine. Now see the difference here with the 2-byte instruction. That means in the opcode fetch machine cycle, the program counter is already pointing towards the next memory location, and at the next memory location, what is there? At the first memory location, the opcode is there, opcode of MVI. Fine. At the second memory location, what is there? The data is there. In the previous all the 3 instructions, we were having only we were having single byte instructions, so it was only occupying 1 byte of space in this. Fine, this much space. So the program counter in the T1 state, in the opcode fetch machine cycle, we were already incrementing that program counter, and it was already pointing to the what was happening previously in the last three instructions. I'll show here. In the last three instructions that we have studied, the code was given here, and at the next memory location, since this was a single byte instruction, it was only occupying 1 byte of space. Fine. So in this opcode fetch machine cycle only, whether there was a memory read or a memory write, we were already incrementing the program counter. So the pointer was already pointing to this memory location, but we were not requiring this memory location to be read or to be written in the previous cases, because that there was no, because it was only a single byte instruction. But in this case, now in the first machine cycle, the opcode fetch machine cycle, in the T2 state, the program counter has been incremented. Now it's pointing where? It's pointing to the next memory location. What is at the next memory location? The data. This data will be read. So what happens? Once this data is read, the program counter now also needs to point to the next memory location. So that program counter has to be also incremented as well as read in this case in the memory read machine cycle. In the previous cases, the program counter was only being incremented and read in the opcode fetch machine cycle. But in this case, in this particular instruction, the program counter needs to be read in the memory read machine cycle as well, because this is a 2 byte instruction, and it has to be, if there are if it's already pointing to the data byte, and already it has to be read as well as incremented so that it points to the next location from where the next instruction will start. So what will happen here? The address bus will now be uh, fed with the memory location that's actually stored in the program counter. Fine. Here you are writing the opcode. Here you are writing the data. In the opcode fetch machine cycle in T1 state, program counter loads the address bus. Why? Because the program counter is already incremented in the previous whatever instruction was taking place. So it was already pointing to this location in the opcode fetch machine cycle. Fine. In the T1 state. In the T2 state, we have incremented it in the opcode fetch machine cycle so that it now starts pointing to this location. And what is at this location? The data is at this location. So we'll be first reading the data we'll be loading the address from the program counter onto the address bus. So this now also becomes your in memory read machine cycle. This is your T1 state. It's pointing to this location. Fine. We have loaded the address from the program counter, enabled the address latch, and in the T2 state now, as usual, what we do, we want since we have to increment the program counter, so increment the program counter. So now it will point to this location. This is memory read machine cycle T2 state. So the next instruction will be written here. Say for example, there will be opcode of a next instruction. So once we do the programming, we'll be seeing that how this is actually happening. Program counter is incremented. Since this is a read operation, the read is made active, and once the read is made active, 87 AD naught now will act as a data bus. And what does it need to carry? It needs to carry the data. And where is that data? That data is actually on the address bus, in the contents of the address bus. Fine. So contents of the address bus basically are fed onto the data bus. In the T3 state, read will be made again low. We'll do doing low to high transition, and register will now be loaded with the contents that are now available on the data bus. Fine. Uh, the address bus has been loaded with the memory location. In this state, we are actually loading the address bus with the memory location where the data is available. Fine. So the address of this location will be on the address bus. Once the once that address bus is read by the microprocessor, its contents, M of AB actually refers to the contents of that address bus, will now be transferred to the data bus. In the T3 state, this data bus, whatever data it's carrying, will now be transferred onto the register. So this is your instruction MBI R, comma M. MBI R, comma data. So this is our 4 instructions. We continue doing the instructions in the